Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Here we're going to taking a look at the zeros of polynomial functions, how they're related to the graphs, and how they're related to the equations. So understand that when your textbook or whatever you're working with talks about a zero, they are also talking about a root, or they're talking about the x part of the x-intercepts. In other words, f of x equals 0. So what input will output 0? That is going to be the zeros of your function. This is closely related to the zero product property. Okay, so let's think about this function. And we're going to be trying to find the zeros or the roots or the x-intercepts. Okay. X squared plus x minus 6. Let's say this is our f of x. And you have to find the zeros or the x-intercepts or whatever, right? Well, if I rewrite this as the quantity x plus 3 times the quantity x minus 2, I'm trying to find out where it equals 0. So that zero product property says x plus 3 equals 0 or x minus 2 equals 0. Solving by factoring, if you want to watch that previous video on how to solve by factoring. And so we'll find out negative 3 or positive 2. Okay, how does that relate to the graph? Well, we know we have a parabola because it's an x squared term, if you've been following all my videos, or if you've been doing this in your own classrooms. X squared plus x minus 6. Let me bring that brightness down. There we go. And if I look at this graph, it is definitely crossing at negative 3, and it's definitely crossing the x-axis at positive 2. So that's where my zeros or my roots or my x-intercepts are. I'm going to use all those words. Why do I have 2? Well, it's quadratic. Okay, so because it's x squared, it has probably one turning point. The end behaviors are up, and we can have up to 2 x-intercepts. And we happen to find 2, one at negative 3 and one at 2. Okay, so because the degree is 2, the number of roots is 2. And I know you might be saying, hey, if it were above the x-axis, it wouldn't cross the x-axis at all. And you're correct. There would be 2 complex roots, but there's still 2 roots. Just because they're not real doesn't mean they're not able to be found. We can always find the roots, we just can't always find real roots. And our end behavior was up and up because this was a positive lead coefficient, which is what this graph is showing us here. So now what if I go ahead, and this time I'm going to give you one in factored form. F of x equals x minus 3, x plus 5, x minus 6. So now, because there's 3 parentheses, the degree is 3. So we should find the number of roots to also be 3. This right here is known as the fundamental theorem of algebra. Okay. Again, they may not always be real roots. In this case, there are. So if you've remembered my previous videos, since it's a positive lead coefficient, it's going to be up on the right. Because this is an odd degree, it'll be the opposite or down on the left. And since it's a degree 3, it can have up to 2 turns. 1, 2. Meaning that we can have up to 3 intercepts. Now, since we have 3 quantities, zero product property says each of them equal to 0. So x would be 3. X plus 5 equal to 0, so x would equal -5. Or x minus 6 equal to 0, meaning x will be 6. So let's check, does our graph actually have zeros or roots or x-intercepts at those three numbers? So x minus 3, x plus 5, and x minus 6. We're hoping it crosses at 3, -5, and +6. Ooh. Okay, so we're not seeing all the graphs. See how we see this gap? So if you're working with one of these, I always manually change my window. I never have the calculator do it for me. I'm going to number vertically by 5s. Let's see if we caught all of it now. Not quite. Got the bottom, not quite the top. Okay, I'm not going to continue working on it. I could. Let's go ahead and go 150. There's that. So now we can see the peak in the valley, but I was only changing my y values. I was not changing my x. We can still see that it definitely crosses at -5, +3, +6. So, oops. There's a reason why I utilize Desmos in Algebra 2 in my classroom, and it's just because it's easier to go ahead and get the window going. Okay, so here we have another polynomial. Technically, this is degree 3 still, because we have x minus 1, and x plus 5. So what you'll notice that if since it's degree 3, I have 3 roots, that fundamental theorem of algebra coming in there. What makes the first parenthesis 0? 1. The second parenthesis 0? Also 1. And the third parenthesis, -5. So we have 3 roots, we just don't have 3 unique roots. So that 1 is used twice. So 1 has what we call multiplicity of 2. It was used twice. So how is that going to affect what this graph looks like? So I've got the y equals typed in here, the f of x, right? And we know that it's going to make that S shape just like the last one. But something's got to happen differently because of that double number happening. And if you notice, it crosses at -5. But when we get over to 1, it just comes down and bounces off. That's because 1 was used twice, so it's kind of like a parabola. So you can see how around the number 1, it's kind of having a parabola shape, and it's got that bouncing effect going on. That's always going to happen when you have even multiplicity. Because that is even, it causes, I call it a bounce. Some books say does not change signs. So we're still getting that S shape going on, but now instead of the x-axis being through the middle of the s's, it's right here. And it bounced at 1 and it crossed at -5. Okay, let's take that up a notch. What if we have okay, now we have to the 4th power. 1, 2, 3, 4. 2 is going to be used 3 times, and 4 is going to be used once. So 2 has multiplicity of 3. Okay. So we had a 2 there, a 3 there, and a 4 there. And because this is the 4th power, I'm going to expect kind of like a W. I'm going to expect some version of that. Okay, up to 3 turns, but the ends have to point the same direction because it's an even degree. There's an even number of roots. Oh, what happened there? Let's go ahead and I'm going to zoom in. So it's like it laid a little S curve there. Okay, zoom. Oh, I might have zoomed out too much. Yeah, definitely zoomed out too much. This is why I don't do it. That's why I always do it manually. So yeah, we're getting this like curve going on here. So we are kind of getting that W look that we kind of thought we were going to have, but instead of a big, it comes down, and then instead of dipping back down, it just kind of curves over. And it's doing that because that's an odd multiplicity. It cut through, or it crossed. So instead of doing any new numbers, I'm just going to come over here. So what if I change this back to a 4? And I'm going to make this with a 2. Okay, so 4 and 2, those exponents are both even. Oh, it bounced and it bounced. You just can't really tell because it's so sharp. It never crossed. So that's kind of it has nothing to do with where it crosses, but if the multiplicity / power is odd, it will cross. And if it's even, it will bounce. And it can bounce from below, it can bounce from above. So it is okay to have multiple values of the same root, but our goal is to find all the answers to a problem. So why did I show you the graph? Well, if you have access to Desmos or graphing calculator or something like that, that relationship's a really big deal. So let's go ahead and find all the solutions so that f of x equals 0. Okay, well, we're just going to go ahead and quote unquote cheat. And we're going to graph x to the third plus x squared minus 3x minus 6. Oh, it crossed it too, but then it didn't cross anywhere else. But I want to find all the solutions, not just all the real ones, and I'm supposed to find 3 answers. So since it crossed it too, I know 2 is one of my roots. So I know x minus 2 is a factor. So in order to help me solve this and find the other 2 roots, I'm going to have to divide by that so that I can find my other 2 factors. It's kind of like when you had 20 is 5 times 4, and then you could split 4 out. That's what we're doing here. We need to change x cubed plus x squared minus 3x minus 6 to x minus 2 times something. That way we can get a factor of 2 and then the other 2 factors as well. So how am I going to find that? I'm going to divide. How am I going to divide? I'm going to use synthetic division. So if you watch my synthetic division video, you'll find out that the a value, or the 2, pops in there. By the way, when it's in parentheses, that's the only time it has one sign. Everywhere else it gets the opposite sign. So that, since that's a minus 2, these are both plus 2. 1, 1, negative 3, negative 6. Or you could factor by grouping, but I don't want to do factor by grouping. 1, 2, 3, 6, 3, 6. Perfect, that's a remainder of 0. So we factored it to x minus 2 times x squared plus 3x plus 3. And we already know that x squared plus 3x plus 3 does not factor because we know the other two answers are imaginary. So again, 2 came from that to get the quadratic down to linear factors, and to find our zeros, we're going to quad formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I can sing faster than I can write. Okay, 9 minus 12, that's negative 3. Okay, so because of that negative, we're going to have an imaginary. So we'll have negative 3 plus root 3i over 2, and negative 3 minus root 3i over 2. We have 3 solutions. 1 real and 2 imaginary, but we have 3 solutions. Okay, let's try that another one like that. Find all the solutions for x to the 4th minus 3x squared minus 4. Okay, well, we're going to go ahead and cheat for now. I will be showing in a future video how to do this without the graphing calculator, because it's very important to know in case you're on an ACT or something, or you don't have access to a graphing calculator. Okay, this made that W, which I'm kind of expecting because it's an x to the 4th graph. I see 3 turns, and I see that it crosses at positive 2 and negative 2. Okay, so my other 2 answers are going to be some kind of imaginary answer. Again, I'm going to use synthetic division to help me. The first time, I'm going to start off with the 2. 1, they skip x cubed, they skip x. If you forget those placeholders, it's going to mess you up. We already know it's going to have a remainder of 0 because it crossed the x-axis. Bring it down, times, add, times, add, times, add, times. Yay! Now that I synthetically divided by 2, I'm going to take that answer and I'm going to synthetic divide by the next factor, which was negative 2. We already know the remainder is going to be 0 because it's a factor. So bring it down. Times, add, times, add, times, add. Yay. And so what we did there is basically we did something like 30 divided by 2 is 15 divided by 3 is 5. That's really all what we did. We divided by 2, then we divided by negative 2, just like you can divide by 2 and divide by 3. Okay, this was degree 4, degree 3, so this is going to be degree 2. X squared plus 1 equals 0. Because the b value is missing, I'm going to solve it without the quadratic formula. I'm going to subtract 1, do the square root of both sides, so plus or minus the square root of negative 1, which we know the square root of negative 1 has a placeholder of I, so it's positive or negative I. So I and negative I. Those are my other 2 answers. I could have done that with factoring as well. I could have said, hey, x squared and x squared minus 4 plus 1. And then I could have applied the 0 product property to both, which I should have written equals 0 the whole time. My mistake there. Set each product equal to 0. Subtract 1, square root. add 4, x would equal plus or minus the square root of 4. So here we'd have plus or minus I, and here we'd have plus or minus 2, which agrees with the 4 things we wrote down. But that would be assuming that you know that that factors.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.